Hi, this is Gautam here. As part of this group assignment, will be my part would be covering about correlation and density-based clustering. So let me share my screen over here. So as you would see over here, so basically correlation is something which describes the relationship between two quantitative variables or two random variables such as A and B over here. Meaning for every unit rise or decrease in one variable, the other variable increases or decreases by the same amount. And we could also see the steps to find the correlation, and we can assume that the relationship is linear for when one unit increases or decreases, the other unit increases or decreases by the same amount. And there is also a similar concept such as regression when we technically speak about the correlation. And we could also see over here the steps to find correlation, where we have to calculate the mean and standard deviation of all the x values and all the y values. And for calculating the standard deviation, we just have to calculate the summation of all the x values and summation of y values and divide the sum by total sum of standard deviation of x multiplied by with the standard deviation of y. And all those steps are mentioned over here. And correlation computation is something which we can see over here. So it has been classified into two steps. So we can categorize it into two main steps, where standardization of data objects happens in the first step, and we'll just take or apply scalar dot product over them. So for example, we'll just consider a data object such as A and B over here, where we uh, calculate the correlation of A and B, and we'll standardize the data using the mean and standard deviation, which we have calculated in the previous step. In the first slide, we have explained about those steps, and we just divide them with the standard deviation, and even for the EB, and we'll just in the end we'll multiply the both the correlation of A and B dot and apply dot products over them. And we can also visually evaluate correlation using scatter plots, and we could find the relationship between the two variables, two quantitative variables or two random variables. And as such as regression, we can also use it for prediction and everything. And the next concept which we are going to see over here is density based clustering. So let me just explain what is clustering, and then we'll go over with density based clustering. So basically, clustering is a task of grouping a set of objects in such a way that objects in the same group are called as a cluster, and they are more similar to each other in some sense or some fashion, rather than the rest of other data points in the other groups or other clusters. So basically, it comes under the unsupervised machine learning technique, where we don't know what to do with our data points, and in order to find the identical patterns or frequent trends among them, we just go with the process of clustering, like customer segmentation, for example, or categorization of customers in as part of the credit card transactions. So basically, this clustering involves all those things. And as part of our slide, we've got density-based clustering. So density-based clustering algorithm helps in finding non-linear shapes or structures on the based on the density. So density-based spatial clustering of applications with noise is the most commonly used density-based algorithm, and it's most widely used. And it just uses a concept of density reachability and density connectivity. So there are three types. Calculation of density-based clustering involves three types. So uh, we've got like Euclidean density, probability density, and graph-based density. And as part of our group assignment, we just got only Euclidean density, so we'll just cover those things in our slides. So Euclidean density, as part of mathematically speaking, Euclidean distance is the distance between 2 points in the Euclidean space, and it's like basically the length of a line segment between the 2 points. For example, if we have in Cartesian coordinate system, we just have 2 points A and B, and we need to just find the distance between the 2 points. So Euclidean density is calculated in a similar fashion, and based on the Euclidean density, the classification of calculating the Euclidean density can be classified into two more types. So one is cell-based calculation of Euclidean density, another is center-based calculation of Euclidean density. So as part of this whole two approaches, it's basically we can say it as two approaches where which differs based on the cell and center for calculating the Euclidean density. So cell-based approach consists of, it's a simple approach where we divide the whole region. We'll just see the data points clustered over here, and we just divide the whole region into a number of rectangular cells and of equal volume. And we just define the Euclidean density as the number of points each cell contains, for example, and represent as a grid or matrix, as you can see, and we can just calculate the Euclidean density over there. So basically, it's a cell-based density is a simple approach. And next is center-based approach. So where so Euclidean density is number of points. So Euclidean density is number of data points per unit volume. As we all know, density is mass per volume. So Euclidean density can be translated into similar fashion as per the Euclidean. Uh, so this center-based approach consists of number of points within a specified radius of the point. So we just calculate center-based density. We just uh, find one data point as a center, and we'll just have to calculate the radius of the, we'll just draw a radius around those data points, and number of points within that radius will be the Euclidean density of that particular center-based approach. So that's how we calculate the center-based approach Euclidean density. And we have also covered the cell-based approach as part of this slide. So if there are any different types of correlation, and I'd like to explain about it. So there are three different types of correlation, first of all. So, and I thought of like explain it via visually. So for example, there are three types of correlation, such as positive correlation, negative correlation, and zero correlation based on the data points. So for positive correlation, so it's more or less like the linear regression. The line would be increasing. So if one variable increases, the other variable also increases, and it goes like this. For consider like uh, if a kid gets receives too much of candy, his or her happiness level increases. So it's kind of like a positive correlation. And if we consider negative correlation, the graph would be like over this. So if you if you earn well, so we can consider two variables such as the once you get aged, based on the age, experience increases, which is a positive correlation. But once you get aged, your productivity drops because of aging factors, and you will get diseases, and you are getting old. So it's like productivity drops down, your productivity or your activeness drops down when you get age. So age is one variable and productivity is another variable, which drops when one increases. So we can say it as a negative correlation over here. And if it's a zero correlation, that is a third type of correlation. It will be like there won't be any change in the data point, and we'll consider the graph is like this. So there won't be any change in the data point, and so it doesn't have any impact even if the one variable changes or not. It doesn't have any impact, and the other variable increases or decreases or vice versa. It doesn't have any impact over that one. So we can say that as like zero correlation, because it doesn't have any relation. They're like mutually exclusive events, so it doesn't have any relation, or it's not related to each other. So I would like to conclude my presentation with this one. Thanks guys. Thanks for giving me the opportunity.